Good morning. We have people entering the room. We'll just wait a minute and we'll get started here. Okay, it's 10:01, so we'll go ahead and get started. Welcome to our webinar, The Surprising Importance of Early Math for Everyone, facilitated today by Dr. Douglas Clements from the University of Denver. We welcome you here today as part of our professional learning project here in Michigan that started in 2017 when GELN, the General Education Leadership Network, requested that the state form a task force. Many of you that are on the call today were part of that early work, and that early work included the GELN representation, ECAN representation, special education, math consultants, higher education from the state, including U of M, MSU, and Grand Valley, the MySTEM network, and the Michigan Department of Education. That work continued.
And from that collaboration come the essential instructional practices for pre-K through grades 3. These serve as our North Star for what we hope to accomplish across the state of Michigan when it comes to instruction in early childhood.
And in October of 2021, for fiscal year 2022, we were awarded a professional learning grant, and that's where this work is coming into. With that grant, we hired Rusty as the director and myself as the professional learning coordinator. And we've worked on creating modules, many professional learning experiences, some that have already taken place and some that are continuing this year. We have a video production team and are creating some really great videos around professional learning, but also inside of classrooms in the state of Michigan. We've revised our school-wide center-wide document that previously existed that focused on literacy, and it now includes mathematics as well, and created an app for early math leaders.
Like Trish mentioned, we have organizational practices that used to focus on literacy across the state of Michigan, and we revised those to also include mathematics. So when we think about the instructional practices that I talked about a minute ago, serving classrooms and what children should experience, the organizational practices serve school leaders and the types of practices that we hope to see in leadership across the state of Michigan.
And we were very excited to be awarded continued funding for next fiscal year for this grant. And so the work will continue across the state. So as we engage with Dr. Clements this morning in the webinar, we'll see connections to our why. We're going to find 5 reasons why early math is an important focus for our statewide work around mathematics. I'd like to introduce you to Dr. Clements. Some of you have experienced his work, and others of you may be new to Dr. Clements. So a brief introduction. He's a distinguished university professor at Kennedy Endowed Chair in Early Childhood Learning and co-executive director of the Marsico Institute of Early Learning and Literacy at the University of Denver. He was previously a kindergarten teacher for 5 years and a preschool teacher for 1 year. He has built on those early experiences in conducting research and publishing widely in the areas of learning and teaching of early mathematics, computer applications, and scaling up successful interventions. His most recent interests are in creating, using, and evaluating a research-based curriculum and in taking successful curricula to scale using technologies and learning trajectories. He has published over 160 research studies, 27 books, 100 chapters, and 300 additional works. His latest books detail research-based learning trajectories in early mathematics education, early childhood mathematics education research, learning trajectories for young children, and a companion book, Learning and Teaching Early Math, the Learning Trajectories Approach, published by Rutgers. We'd like to welcome Dr. Clements and give him the mic.
Thank you very much. Appreciate it. We talked before you guys joined us and emphasized, please use the chat to ask questions anytime you like, anytime. And Trish and Rusty will try to interrupt me if I don't see a question in the chat that would be fun. It's much more fun if we interact during the whole thing. So please feel free to ask questions, disagreements. Put in your own ideas and the like. That'd be great. Okay, so surprising important or early math. Before we start, let me ask you, how did you feel about early mathematics when you were a young child, right? It's so different. Did you feel like A, B, C, or D? What was your basic feeling? So what I'm going to do is open a poll on how you feel, and it's anonymous. Nobody will know what you entered, but let's take a look and enter it, everybody. How did you feel? What's the closest? Oh my gosh, we even have some people doing D. That's not very often chosen. Very good. Let's see how we're doing. Oh my gosh, almost everybody responded. Thank you very much. It's so nice when people jump right on the polls like this. Couple more seconds and we'll have everybody. All right, I think we've got everybody who wishes to, so let me share the results here. There we go. Are you seeing that, Russ and Trisha? I can see you nod. Okay, super. So yeah, A is common, B not so common. I love it. I mean, the fact that we haven't destroyed people's enjoyment in mathematics is a wonderful thing. Too often we get the C and the A kind of responses, right, from people. And it's because we don't teach math the way we teach other subjects that we love, like language and literacy. In fact, one person who's a science and math educator I used to really like said, if we taught literacy the way we teach mathematics, kids would go pre-K through 12 and never read a book and never write a poem. Mathematics has the same kind of engaging sections to it, but we don't always involve them. But I'm glad for some of you, at least, you know, that was it. For the others, I sympathize, because we need better mathematics in our society. If you can read that a study finds parents can do 1/3 of their kids' math, but struggle with the other 3/4, you know that we haven't done at least a very good job with fractions. So we need better mathematics. And before I get into what's surprising, could I learn a little bit more about you by doing one other quick poll? I think it comes up in a second. Actually, I'm going to show the poll in a second. So let me do, there we go. But let me do this. I forgot. This is available. Trish and Rusty will make sure you know where to find this. I don't share slides usually because slides are very often just visual and it doesn't contain a lot of the information, but I do have a publication. It's just a brochure, like 4 pages, that talks about the 5 important things we're going to talk about today. So that'll be shared with you. And I wanted to say that. Okay, on to the context now. Here's the kind of thing. In what context are you teaching? You know, and then your role in it. So let me get that poll going. Launch. And just fill that out for me so I learn a little bit more about who we've got with us today. Oh, thanks. Thanks, Trish. Trish has put a link to the Google Drive for that. But don't read it ahead of time. I'll be even more boring than usual. So just keep it for reference. There we go. We got almost everybody. Anybody else who wishes to put it in, it's totally optional. And again, all these are anonymous. So, all right, I'm going to end that. Sorry if I ended a little too soon for you. So here we go. That's what it looks like. So we've got a nice range, infants and toddlers. We got 11%, 22% teaching threes. The majority, which we knew, were teaching fours, but some kindergarten and some primary people. You guys are heavily going back to face-to-face with still some blended and a little teeny bit remote. And we got teachers, leaders, supervisors, and other. Does anybody, would you mind, if you don't mind, if you're other, could you shove that in the chat for me so I kind of see some of those roles? That'd be great. And I am going to close that down. Math consultant, super, coordinator, instructional coach, interventionist, curriculum specialist. Oh my goodness. Okay, coach. A lot of coaches. Great. This is fantastic. I hope I answered the questions you have. Consultant again, higher education consultant too, several. Okay, super. Thanks, guys. But since we have a wide range of roles, it's especially important to kind of stop me, ask the questions you have about what's that, what would be important to you about what I'm talking about in your role. I'm happy to try to address that. So let's go through some surprises. First of all, early math is just surprisingly important. Learning early math from birth on, really, but certainly infants and toddlers right on, helps to develop kids' cognition, of course, language, but also executive function. And language, we're going to talk about that. It's surprising effect on language. I'll get to that later. Social skills, if done well, so that you're not A or C with your kids, and emotional competencies as well. The kind of efficacy kids get, the kind of feeling that I understand mathematics is a little different than things like even science or especially social studies, because kids at a very early age, let me tell you about one preschooler, already off the topic, so sorry, but here we go. Mary Elaine Spittler did her dissertation on kids, 4-year-olds, understanding of triangles. And the class was having a discussion that she was following one day, and the teacher drew a really long, skinny, you might know it as obtuse, if you remember that language, long, skinny triangle on the chalkboard. And the class was arguing because some kids were saying that's not a triangle. It's too skinny. It doesn't look right. And a 4-year-old got up, pointed to the triangle, said, look, it's got 3 straight lines. It's got 3 corners and it's closed. That's a triangle. It has to be a triangle. This kid had the kind of feeling of autonomy. She understood that she knew the definition. She could prove it with the facts. She did a preschool version of a proof in mathematics. And that gave her the kind of confidence. She did not have to wait to what the teacher said about it. She could decide it for herself. Over a lifetime, these kind of positive effects really compounded. We all benefit from investing in early childhood math learning. Okay. So the participants, Rusty, can't see the comments, or can they choose to send it to everyone, or no? Not in this webinar context. Maybe not. We'll make sure we pass on the contact, Rusty, and please feel free, Rusty and Trish, to unmute and share them out loud then, should they be important if I don't see them. Thanks for that, though. Okay, building on that, surprise number 1, there is more and more evidence of math's predictive power. What do I mean by that? Oh, Greg Duncan and his colleagues did these studies over years. This is just one of them, an early one. Tens of thousands of kids, hundreds of individual studies with those kids. Each one of these little teeny triangles is a study. The higher you go here, the higher kids did on grades. Then across the x-axis here, horizontally, they looked at beginning reading, in other words, entry to kindergarten reading skills, and that was predictive. Attention, internalizing and externalizing problems and social skills were not. They were mildly predictive, but see the 0 here? That meant they weren't really predictive of later school success. That does not mean they're not essentially important. It means that early childhood educators tend to do such a good job on those things that they no longer are barriers to kids. However, look at the most predictive one of all there. Early mathematics stood out as predicting later school success in all subjects beyond all the other predictors. In fact, early math predicts high school graduation and college entry, and persistent elementary math problems were a reliable predictor as well. And even farther, this is shocking to me. Number and arithmetic knowledge at age 7 predicts how much income you make at age 42. I mean, that's just shocking. Preschool math predicts how well kids do in math at 15. Laying that foundation is so important. And this is older than our crew here, but this is still a really interesting study for you guys who are consultants across the grades, especially, and supervisors and your other roles, that if you know science, you know that like the biology people think that their field in science is the most important, and chemistry feels that they're important in college. Physics people will always tell you, if you understand physics, you can understand all the others because it's harsh. You know, the world is built on physics. So what they did is they did a study where what's this showing is this is your college biology grade if you took high school biology courses. It's higher. Now you teach it, you learned it in high school, you do a little better in college. However, how much chemistry and physics you took didn't really help. It goes across 0, right? These so-called confidence intervals here. Okay, if you took high school chemistry, it helped your college chemistry. Physics actually hurt, although it's not statistically significant. And if you took physics in high school, it helped your physics, but it doesn't seem to have an overlap with the other subjects, except, ooh, wait a minute. What's the black bar? If you took more math in high school, you did better in biology, chemistry, and physics. Math remains the queen of the sciences, and with the emphasis on STEM we have nowadays, it's really important to do a good job with early mathematics. Okay, let's move on. It's surprisingly important. That's number 1. Surprise number 2 is children's math potential. Young children can learn an amazingly broad, complex, and sophisticated mathematics. Let's just take a look here. There we go.
Five.
Good. How do you know?
That's Julie
I know
interviewing.
from 4 to 8. So when I think of 9, I know that there's one more. So if I take away 4, it's like take away 4 from 8. So there's one more still hanging down. I'll put the other. That's 5.
Good.
With a little girl, a 4-year-old, 4.5, who's very pleased with herself, solving 9, take away 4. And I hope I didn't talk over it and you got enough of it there. But it's really interesting, not only that she can do subtraction, not only that she uses a strategy, she didn't memorize the fact or anything, but also, to me, you know how a lot of people think, based on old notions of Piaget, that kids need concrete objects when they're young to do mathematics. but was she doing it concretely or not? It's not always completely obvious because, oh, Rusty, good one. Just to tell you quickly, if you have a question, try out the Q&A button at the bottom of your screen, and that'll be a good way to do it too. That might be better than the chat, which I emphasized chat at the beginning, but that'll be great. Anyway, she said, I knew 4 and 4 is 8. So then I had an extra one, and she actually takes it and moves it up off the table. So it seems abstract, but she's moving them around. And then did you see her? She said, and then I take away 4, and you can almost hear it hit the floor when she drags it off the table there. And then she said, and I got one more hanging on, and she goes and reaches it and pulls it back and said, and that makes 9. Oh, that makes 5, sorry. So again, amazingly competent if given the opportunities to learn. Surprise number 3 is this all is quite a surprise to educators. What children can learn is a surprise to too many educators. And I was going to do a poll here, and I didn't send Trish the right one. I sent her a copy of one. So I'm going to skip that. But I will tell you that what happens is if you look at the prediction of preschool and kindergarten teachers to what kids can do when they enter kindergarten, the teachers that had them and the teachers that are receiving them both underestimate the capabilities of kids. So we need to really kind of up our game. And I love what Russ was showing, that the document is really a good way, because it lays a path for that for sure. We know from reports, moving on to this competency thing, that kids from low-income backgrounds, for instance, enter school with far less knowledge, and that gap in knowledge progressively widens in too many school settings. But what's important to realize is that although school mathematics is not working well enough, here's an international study that, for instance, that shows, United States is here. We don't do particularly well. But the important point I'm making here is what people don't always understand is where our kids who live in the best funded areas of the country, where do they perform? Second in the world. But the kids who have fewer resources to learn are not performing that way, because there's a 10-to-1 difference. We need to have equal charging stations for early mathematics and other subjects across every state and neighborhood, so all our children have access to high quality early mathematics. And it makes a difference. You've seen these international comparisons, top performing students, there's a lot fewer in the US. US students are outperformed in mathematics by a lot. When you look at those kind of levels, we can do better. We can do much better. And there's a lot of resources, and I'm going to show you some that are free. These National Research Council report, I was on this committee, and that's all those kind of reports. National Research Council from the National Academy of Sciences of Engineering and Medicine. I'll be talking about a couple of those reports. They're all free online, and they have good executive summaries, so you don't have to read the whole thing. So in this report anyway, we agreed, but we made the point that's really important. It's an opportunity gap. It's a gap in the number of charging stations communities have for early mathematics. And if we close the opportunity gap, it is not that kids don't have the capacity to learn. It's absolutely incorrect to presume that. It's a learning gap that comes from the lack of resources. And that's why we subtitled this thing Learning Paths. That's important, because learning paths is just a simplified name for what I'll talk about as learning trajectories today towards excellence and equity. These kind of learning paths are so important to make sure kids are met at their level and help to grow and develop like they can. Evaluations then show little or no learning in math in the earliest years in too many settings. Children actually regress on some of the math skills they have in pre-K. And I'm going to give you an example of that later. And others come to believe math is a guessing game and a system of rules without reasons. So we need good curriculum, good teaching. And without it, they develop pretty destructive patterns in mathematics. And those of you that thought mathematics was just too hard at the beginning know what I'm talking about. So moving on. So what did we say?
Dr. Clements, can I pause
Yeah.
for just one quick second? There's one
Mhm.
question in the chat.
Wonderful.
You mentioned charging stations. Can you elaborate on what you mean by charging stations?
You know, I'm going to put my Q&A window over the top of the chat, and we'll use that one. Julie asks, yeah, okay, Julie, it's just a broad metaphor. So all I mean by that is the vast number of resources that different areas of the country have. You know, when I put that slide up, there's a 10-to-1 difference in those kids that were well funded, and that means everything. So it's a global term that means there's not enough, seriously, just funding for the schools, that because we base things on property taxes and things like that, it's not equitable how much schools have to spend. Teachers are working under really, really difficult positions with less salary often, less resources in their classroom, looking around for things like curricula, like materials, like manipulatives and the like, more in areas of the country with fewer resources. Parents have fewer resources. There's more toxic stress in there. There's people in single parent homes working 2 jobs. These kind of things don't give the kids the resources, the charging stations to talk. There's nothing in any of the cultures that is any less capable of supporting mathematics. But when you don't have the time and the resources in the community, in the schools and the like, then those are the math charging stations, that we need to get in all areas. Tell me, Julie, I got the question and answers right open. So tell me if that wasn't enough, and I'll try to talk more about that. Most kids need better math too, though. In the present pre-K and kindergarten, and not in Michigan, maybe. So you could tell me I'm wrong on you guys, and I hope I am. But across the nation anyway, children engage in the math content only 4% of the day in pre-K and 9% of the day in kindergarten in recent studies. And almost pre-K and K teach too much of the same content. So take a look. This kind of counting and cardinality is 64% of what kids do and 59% in kindergarten. But in a preschool where kids do learn counting skills, counting to 10, sometimes counting to 20 and the like, to go over that again in kindergarten is why Mimi Engels and Amy Clayson's research on math in kindergarten, not almost, the majority of math that too many curricula list and too many teachers teach is stuff the kids know when they enter the door. So we don't move the kids up through levels and the like. It's too much of the basics. To nail this down, this comes from Dale Farron's research. To nail this down, there's too much simple counting. The more counting people do in kindergarten, actually the less kids learn. Simple counting. I'm talking about just verbal counting to 5 or 10. Counting objects, but not solving problems with counting, not doing interesting comparisons with counting, not getting strategic about the counting. So we need to move up. So Q&A, we already got one. Does anybody have kind of a thought of these first 4 surprises? Because we're going to spend the rest of the time mostly on the 5th one, right? That we know a lot from research. Is there anything there that's either relevant to your situation you would like to comment to people? So it's Q&A, but you can do the answer part too right away. If you have some thoughts on things you're doing or things you need to do, or ask me questions. Does that data about counting include skip counting? No, Lily. Excellent point, right? I'll dive into counting, Lily, a little later if we have time. But that's what I'm saying. Strategic counting, different types of counting, bridging tens. We just don't do a heck of a lot of often nationally, even in kindergarten, you know, so kids go up to 10 or 20. The trouble is, you know, in our language, in English language, right? You don't even see 1, 2, 3, 4, 5, 6, 7, 8, 9 in the teens. In fact, 15, kids skip 13 and 15 because they don't relate it to 3 and 5. While you're typing questions, let me do another off the track, a kind of thing. Japanese, East Asian languages tend to have a different structure with the teens, and it really helps kids learn both 1 to 10 and place value sooner. Why? Because they count like this: ichi, ni, san, shi, go, roko, sichi, hachi, ku, ju. Ju ichi, ju ni, ju san, ju shi, ju go, ju roko, ju sichi, ju hachi, ju ku, ni ju. What did I say? 9, 10, 10, 1, 10, 2, 10, 3, 10, 4, up to 10, 9, and then you say 2, 10. 2, 10, 1, 2, 10, 2, 2, 10, 3. So the trouble is, if you only count to 20, everything's arbitrary. You don't see a structure there unless you talk to kids about 11 is 10 and 1. You can do a lot with the English language. Spanish is just the same. You really got to memorize the teens. But the more important thing is to go beyond 20. So kids start hearing 21, 22, and talk to them about 20 means 2 10s, because in the East Asian languages, in Japanese, niju means 210. Niju ichi means 210-1. Niju ni means 210-2. So, you know, we can do so much more with that. But anyway, Lily, I'm far off your question. Anything we're counting above like that, counting on from one number to another. And I'll try to return to this if we have time when we get to counting. Julie and I have more sessions with you in the future, and we will dig into counting and where you go with counting that changes the whole landscape. Counting goes right up to 2nd grade if you do meaningful counting. So skip counting is right. Counting from different numbers, counting forward and backwards from any number, counting counts leads into arithmetic and the like, Lily. So that was a great question, because it really is important. When I said simple counting, that's what I meant. Nothing like Lily's naming. Brianna says, have you found that teachers who are not confident in their own ability are the ones who aren't as open to children's potential? Most of the time, Brianna, that's exactly right. There are teachers who are gutsy enough to say, you know, I wasn't good at this, but I'm not going to pass that down on my kids. And they're willing to at least get kids into discussions and talk about them. And they can have wonderful effects on kids. But it takes really a forward looking. You probably know, Brianna, that many, I hope it's less nowadays. When Julie and I started this work now 2 decades ago, but when we did the empirical studies for the next 14 years, many preschool teachers would tell us, you know, I got into preschool so I wouldn't have to teach math, and now you want me to teach math. So Brianna, it's a serious issue, and very often they don't want to teach math because they are the people that picked A and C, right? It's either so hard or it's just so boring. And unfortunately, that's the way we taught too much. Patrick, maybe typically I have students that cannot even count to 5 yet. Yes, a good one. Does that mean we should begin with adding the mathematical sentences? Whoops, it's skipping on me. There we go. Does that mean we should begin with adding the mathematical sentences even when they cannot count? No. So that's another great question. Many kids have it. When they don't have it, you've got to get down to their level. But believe me, that it's important to, they can ratchet it up pretty quickly. I think I won't tell all my stories yet. I think I'll get to them during the talk and come back to that. You really need to do it. I don't know if you guys have been involved in the discussion of remediation versus acceleration, with a big push that remediation is no good and we have to accelerate, we have to teach the grade level stuff. In mathematics, mathematics is very sequential and hierarchical. So I agree that remediation has been a failure, because what we often do is take those kids who come in and can't count to 5, and we leave them on a low track for the rest of their school careers, and they never reach it. So this is just bad remediation. But acceleration, teaching at the grade level without that foundation. Julie directed a dissertation when she was at Wayne State University a few years ago, quite a few years ago. And the person did you might know, it's in Detroit. She went into a classroom that didn't have much resources, and the person just did a study where she asked kids, what do you do when the teacher teaches mathematics? And one of the most poignant answers was a little 5-year-old boy who couldn't count to 5, but the teacher was doing addition and subtraction in 1st grade. And he says, I know what I do when she teaches mathematics. I just shut my mind and I listen to the teacher. We do not want kids to shut their minds off and just try to memorize what the teachers, those are the kids that the teachers will say, he knew that 3 + 4 = 7 last week, and this week he forgot it. No, he never knew it. He had a trivial memory of the rote words to say, and he didn't have the foundation. So I'm saying, go down to that kid. But the best thing about learning trajectories, it can help us accelerate kids through the levels they need to build to have a firm foundation. Okay, Lily's back again. I had my own early learning instruction. Japan, no, Lily, that's so cool. My foundation was different than my classmates when I moved to the United States in 2nd grade. And I'm assuming the little smiley face meant that you had a better foundation, Lily. And that's too often true, although we can fix it, right? Rote counting has become the stable on school readiness for pre-K students. Society does not understand the importance of problem solving because we most likely never had this experience either. Crystal, what a wonderful comment. I could just read your comments. We don't have to hear me present it all anymore. This is great. You are just absolutely right. And when I was saying we do too much basics, simple counting, but simple all mathematics, that's exactly right. Counting can be used to solve problems, right? I mean, from the very simple, can you get enough scissors for your table? So it's not just counting the people at your table, and then you got to go over to the scissors and you got to count out the same number, then you come back and it's a check, did you get the right number? But it's still a simple problem, all the way to, oh boy, so you got 13 and you got 7. How many do you have to give him so that you have the same number? That's a really hard problem, but it's a counting-based problem that you really have to think about. You can't find the difference 6 and give them all to the person with 7, because then that person would have 13 in the first and the other person has 7, so good one. And Renee says also, goal, having effective charging math stations across Michigan that delivers high quality mathematics to all communities. Renee couldn't have said it better. Wonderful. So how do we do it? The good news is, the surprise number 5 is we know a lot about how kids think and learn about mathematics. In fact, mathematics is such an interesting domain because of its cognition, its reasoning, it's all that educational psychologists, cognitive psychologists, early childhood educators, teachers and researchers and everything have all done research on early mathematics, and we know a heck of a lot from birth right up to age 8. Little less as it goes up, actually, but it gives us in early childhood a great tool to use, and that's what we use to make learning trajectories. So there is a science of early mathematics education. What is a learning trajectory, and why do we think it's important? Well, there's research on mathematics that has helped us develop standards. That's a red line. There's research on how kids develop these ideas by developmental psychologists. I left them out of my list. They're very important here, who has helped us build assessments. And there's research on teaching that has helped us build curriculum and instruction. But Julie and I think that only a scientific approach to learning trajectories weaves those 3 bodies of research together so that our goals, standards, curriculum, teaching, and assessments can all come from a common research base. And that's why Julie and I really believe in the power of learning trajectories for standards, curriculum, for sure teaching and learning. They have 3 parts, every learning trajectory. They're topic specific. So for every math topic, there's a learning trajectory that has a goal, a developmental progression, and teaching practices. So just speaking about the goal for a second, okay, you know, it's very consistent with Michigan Essentials. It's, on that first page, and Rusty was showing this too, the values, absolutely. Those are the most important values. They go beyond behavioral kind of objectives for sure. And they say they understand children as mathematics knowers, doers, and contributors to the field of mathematics. Just so well done. And they include objectives, sure, but they also include the big ideas of mathematics. So these are kind of the big ideas of mathematics we developed with people from across the country, actually, years ago. So let me just give you an example. If they're in these areas, these typical kind of big domains, but just to give an example of number and operations, we say numbers can be used to tell how many, describe order, and measure. They involve numerous relations and can be represented in various ways. And the same thing, an elaboration for operations or addition, subtraction, multiplication, division, and the like. So these kind of big ideas, the research shows that teachers who keep these big ideas in their minds as they're teaching just do better with kids. So it's important to know what lesson you're doing, where you are in a learning trajectory, everything else, but the goal should be these kind of big ideas, not just a row counting crystal. Absolutely right. So I thought I'd use an example for a learning trajectory. Subitizing is a pretty straightforward example, which is why we bring it up, Julie and I, often first, but it's also an underappreciated piece of early mathematics by too many in education. And by that, I mean everybody. People write standards, policies, curriculum, etc., not just teachers. Here we go. So what is it? Well, you don't have to type this in for sure, but what do you see when you see this? Most people say, I saw 3 trees. And since it was shown on the screen and I didn't do it quickly, we call it recognition of number. It's an early ability to attach a label to kind of something you're looking at. By recognition of number, some teachers, just a warning, will logically think we mean reading this, being able to see this and say 5. We don't. That's a really important language arts skill, but it's not what we're talking about with recognition of number. We're saying you probably didn't need to count to say 3 trees. Maybe you said 3 trees and water and fences. You're very elaborative. That's fine. But basically, most people know that they saw 3 trees without counting. So a learning trajectory is a path to develop that goal, which is to be able to recognize quantity without counting, which does not replace counting in any way, shape, or form. It supplements it. And I'll try to make that clear as we go on. Julie likes to think of learning the developmental progression as a garden path, and learning trajectories as a way to help kids move from one step to the next till we get into that gate, which is our metaphorical garden there. Okay, so let's go over the three parts then for this kind of trajectory, this recognition of number and subitizing topic. The goal is children recognize and then quickly recognize the number in a group without counting. Look, I have 3 blocks. Doesn't need to count them, right? And later, even I have 6, 4 here and 2 here. We'll get to that in a minute. And I would share with you this website, learningtrajectories.org. And there's a handout that's equally, I bet Trish is going to go put it in the chat for you, a link to the handout that tells you about, it's just a reminder to tell you about this website. It's called Learning and Teaching with Learning Trajectories. So the initials are LTLT. So we call it LT squared. If I say that, that's what I mean. It's just referring to this learning trajectory. LT squared is one of those math jokes that has extremely limited humor value, but that's how we refer to it many times. So anyway, here on that learningtrajectories.org website, you can open up subitizing by clicking on this arrow here, and you'll see a little thing said learn about subitizing. I would never subject you to a webinar in which I show you a video of me talking. So I won't do that, but here's a video of me saying why it's important and a little bit about subitizing there, should you be interested. Let's move to the next part though, developmental progression, that garden path, right? When you open it, there you go. All those levels are below, and I will first give you the big picture, and then we'll talk about some of the levels. The developmental progression is the typical path kids follow from moving from one level of thinking to the next. Again, learning trajectories are powerful because the research in early childhood tells us what that path is. Like kids learn to be stable instead of floppy all over first, and then to lift themselves, their head ups, then to crawl, then to walk, then to run. We know a lot about how things develop, and we wouldn't teach to target. We wouldn't say we want our kids to walk, so when they're like 3 weeks old, I'll just hold them and force them to move their feet, walk. And no, we hold them the right way, so they have to support their own heads. We make sure they get free reign of the room when it's time to crawl. We don't keep them in a crib all day or something like that. So it's all in its time. So the broad strokes of the developmental progression for recognition of number and subitizing is this. First, kids develop the approximate number system. What? If you haven't heard of it, now I'm sounding like I'm coming out of left field, but I got a really cool video to show you what that means. Kids are virtually born with sensitivity to number, and it's not through counting. It's through this kind of quick recognition of small and larger sets. I'll get into that in a minute. Then they learn to recognize the number. So this is just an intuitive early thing. This recognition of number is what I mean by that is they can label it. They can tell you that's 2. They can tell you that's 3. That's really important, but it goes beyond the kind of implicit, intuitive, environmentally gift that we have on quantity. Then they learn to perceptually subitize. Subitize, Latin word that means suddenly. All this means is we're tying this intuitive thing quickly to the ability to say number words. Julie and I aren't like, oh my God, all math should be fast. That girl you saw do 9 take away 4, I think it was at the beginning. She actually went into a 2nd grade in 1st grade because she was like kind of knew the whole 1st grade curriculum. And the 2nd grade teacher actually argued she was too slow on her facts. She should go back to 1st grade. And the parents had to go in and talk to the teacher and the principal. And the principal backed the parents up saying, she basically told the second grade teacher, wait, how's she do on the facts? And he said, well, she's slow on them, but she gets them all right. Well, do all your kids get them all right? No, but they're faster. She said, why don't we just keep her in second grade and see? Well, the girl ended up going 2 years early in 7th grade to the University of Buffalo's gifted math program. Not all things have to be fast, for sure, to be good mathematics. Slow, reflective thinking, very important. But there's a super advantage to subitizing fast, because it gives you room in your working memory to do so much more interesting thinking if you can recognize these things quickly. And it's built on an environment, evolutionarily built-in kind of key that we can recognize these things. Anyway, then perceptual subitizing goes to conceptual subitizing, and I will explicate that in a second. But let's go backwards. Let's go to that first level, the approximate number system. What does that mean? Here's a baby in a cognitive psychologist's laboratory, actually a pair of them. Libertis is the one. Melissa Libertis is the person who shared this video with us. See that star right there in the middle? They're going to show this baby, this star, to focus his attention in the middle. And then they're going to show in rectangles up on the upper left and right, they're going to show sets of objects changing. They change in color. I'm not sure about that. They change in size. They change in arrangement. They change in density, how dense they are or how much of the surface they cover. But only one side will change in number. So what they're interested in is, what is the baby going to look at more? Can the baby tell the difference? So do you see, look left, look right, look left again? Do you see that? Let me just do that. Oh, darn it. Sorry about that. I'll get back there. There we go. So watch. When the two rectangles come up, watch the baby rather than the rectangles. Looks left, looks right, looks left, looks right, left. I mean, I know it's the baby's right, okay? I'm just giving you which side we're looking at. But do you notice now? Ooh, there's a lot more interest in that side. And you can notice that that's the sides that's changing in number. So although there's a lot of distracting things on both sides, and the baby checks, did you see that look? Real quick look on the other side. But no, that baby likes that. That baby is excited by the change in number. Look at that. I mean, this is enthusiasm for a change in number coming from a few months old infant. And then the infant is not going to give up on the other side. Ready? Look, are you changing in interesting ways? No, I really prefer the other side. This is the approximate number system, a built-in sensitivity and interest in number that does not rely on knowing any number words, much less counting. So this is what 98% of the kids come with. There are kids, dyscalculia, children with certain kind of specific disabilities who aren't sensitive to number like that. And it really makes a difference, and we have to work with them in different ways. The vast majority of kids are sensitive to number. Okay, remember that was the earliest developing level. The next one is recognition of number. That's when kids can just look and say 3 doggies. Because tying the number word to the what you're looking at takes some thought early on. They can't tie it to their ability to recognize, to be sensitive quickly to small numbers. They have to see it for a bit. That's just because they're learning the vocabulary. And then they move to perceptual subitizing. So have you had the experience of perceptual subitizing? You ready? Just look at the screen and I'll show you this. It disappears. And all of you could say 4, right? That is perceptual subitizing. We are just hardwired to be sensitive to small quantities. And we've learned to be able to put a number word on it. Now, what's conceptual subitizing? Conceptual subitizing is, ready, this. And you all can say, well, 8, I just saw 8. Well, did we? The research shows pretty, whoops, I didn't show the 8. 1 second. There we go. Oh, it disappeared again. Sorry, I meant it to stay up there. You saw 5 and 3, and you can put it together. Most people honestly see 8 phenomenologically, but if they put us in one of those kind of things that they're measuring our brain waves, they can tell that actually we do recognize the 5 and then the 3, and then we put it together and into 8 in 0.2 of a second. So we have learned to take those early kind of sensitivities to number, label them, and even combine them. So it isn't a baby skill,
Okay,
only
just
perceptual
a quick
subitizing.
moment.
Let's watch this girl.
I'd like you to tell me how many grapes there are in this card. Remember the grapes? Ready? Just for a quick moment. How many grapes?
10.
Good girl.
I wasn't even counting because I knew it was 2 5 makes 10.
That's right. Well, you've learned a lot, haven't you? Now I'm going to show you a card with some pennies on it. Try to tell me how many pennies are on this card when I show them to you, just for a quick moment. Ready?
$15. I'm like the smallest kid in my class.
Okay. Maybe we don't want elitism or competition on who's the smartest, but we do like the confidence, right? So it's, what's fascinating there is she could not only subitize the 10, but we wouldn't put her above a subitizer to 10, even though she got the 15, because did you see what she did? She could see that there were 3 5s. She knew 5 and 5 is 10 like that, but then she counted on, and she even knew to keep track. So I think it was Lily who said, skip counting is at a higher level skill. So is counting on keeping track. Think of that. Okay, I got 10. I have to know the number after 10 without counting from 1. I have to know the next number. That's, you know, that's a competence that I mentioned before. And then I don't want to just think I'll count 5 more and keep, you know, and mentally just know when to stop, like 10, 11, 12, 13, 14, 15, 16, 17, 18, I don't know where to stop. She knew, oh, I'll keep track. 11, 12, 13, 14, 15, 15. That's a combination of subitizing with a really advanced skill for a 4-year-old of counting on keeping track. That's just, she's just doing so well at mathematics, thinking so well and enjoying it. So that's why we put her level, by the way, here, not up at 20, because she didn't recognize the 15 like that. And we're not criticizing her for that. Oh my God, for a 4-year-old, she is just moving. So here's another example.
Take that snapshot. How many fingers? 3. So how many did you have? All right.
Lucky guess is 5.
Okay. Go to count again.
5 still. That'd be 6. That would be maybe that would be 5 again. 6. 2 is 4. We have 4 on this hand, and 2 more is wait, 4, 5, 6.
Again, what level? Think to yourself for a minute, just for fun. Okay, I lied about a minute. I gave you 10 or so seconds, but you know, we thought maybe conceptual subitizer to 5 for her. She wasn't. I put the rectangle down for perceptual subitizer to 5, and I can understand where somebody would say, I don't know, I thought perceptual subitizer to 4 because she got some 5s wrong. Yeah, she did. So it, you know, she's somewhere in that range, and learning trajectories, it's not like kids are at one level and then all of a sudden on their next birthday, they're at this new level or something. You know, they got a foot in several levels, but this, we know, I think you could tell right there what kind of experiences would be good for her. Anyway, conceptual subitizer to 10 then is the ability to see 2 different sets like that. I'm going to show it again just in case I talked over it here, right? 2 different sets like that and immediately see it. Conceptual subitizer to 20 and is the next level. And we're past preschool now for sure for virtually all kids. But think about this. If you can conceptually subitize to 20, if you can see, you know, 8 and 8 and no 16, if you can see 5 and 7 and no 13 visually through these kind of presentations, you basically have all your basic facts with meaning. There's this study by Brown and Henry a while ago in California, and they used to have these kind of meaningful standards that were based on the National Council Teaches Mathematics. They were similar to Common Core, but in a very early version. And the Department of Education in California back then, this is quite a while ago, got kind of hijacked by some very conservative mathematicians from Berkeley. And they threw out problem solving. Lily, they threw out, somebody else said problem solving. I don't think it was Lily. And they said, learn your basic facts. And you can't sell a curriculum in California unless you make sure all kids memorize the basic facts by the end of 1st grade. And in 2nd grade, you cannot support them learning basic facts because they should already know them. And it was a disaster. 7% of the people knew, kids at the end of 1st grade knew their basic facts, 7%. Well, did some teachers do better? Yes. And you know what? They didn't use the new textbooks that force kids to memorize. What did they, did they use time tests? Nope. What did they do? They did conceptual subitizing. They taught kids counting skills. They, including skip counting, by the way, and counting on and everything. They worked developmentally with where the kids are and didn't try to immediately run to fast basic facts without meaning. It just doesn't work. It's not effective. So this conceptual subitizer with place value, let me show that video, not video. It didn't come up. I'm running out of time, so I'm gonna move on. But I hope you saw it for a minute. We use 5 and 10s frames to structure so kids could see, you know, a kind of 8 and then a kind of 5 in 5 and 10s frames. And they can visually think, if I move these 2 over into the 8, that'll make 10, and I got 3 left. They can see that. And so the basic facts have a conceptual background. And this is kind of what the Michigan Essentials say: intentionally select and implement cognitively demanding mathematical tasks from instructional resources. I love it. Couldn't be anything better. Cognitively demanding means be on the working edge of where kids are. And if your kids can't count to 5, the counting to 5 is that edge, but most kids can't do it. And I mentioned that 1 or 2%. Could be different. Most kids can't do it because they haven't had the opportunities. Given the opportunities, I will show you some graphs if I don't completely run out of time that show those kids will catch up to the other kids if challenged at their level. It's got to be challenging but achievable. All my friends in NAEYC, the National Association for Education of Young Children, you know, they always talk about developmentally appropriate. Doesn't mean developmentally easy or non-challenging. They mean challenging, but achievable. That's what Learning Trajectories is all about. That's what the Michigan Essentials is all about. So teaching practices, got to move. The website I showed you before, free, by the way. All you do is sign up. I can do that if we have time, but the documentation you'll have will walk you through that. You do have to sign up, but it's absolutely free to you and to everybody else who wants to use it. Oh, got a new question. Let me pause for a second. Before I pause and read the comment, if you want to develop this level of skill, you go there and you read and you see a video at that level. Below it are all kinds of free activities that teach you. And when you click on any one of these, like this is to teach subitizing, we call it IC numbers. In other words, the teachers that just use the kind of number words all day to say, instead of saying there's blocks on the floor, got to pick those up before we can go to music. Instead say, oh, 3 blocks on the floor. Can you pick up those 3 and then we'll get going to music? That's all. That's all. It makes an incredible difference. Okay. Infants are fascinating. Thanks for showing us that infant video. Sure. As they grow, we have to continue to facilitate math skills. Absolutely. In math development. When can we expect kids to cross the decibel line, the 9, 10, 11? Forgive my spelling. No, your spelling better than mine. And how do we best facilitate this skill? Does subitizing feed the skill, or do the 2 skills develop in different parallel paths? Boy, I wish I had 2.5 hours with you guys, because I meant to try to combine those 2 paths, and I still will in the remaining minutes. That's a wonderful question. Yes, subitizing, by the time they're subitizing to 10 and 11, you have definitely got them counting to 10 or 11 or beyond too. The 2 things are like this. The subitizing and counting come from different directions. Counting goes way farther. Counting, you might know, if you ever took advanced mathematics, counting is the basis for probability theory and this and that and the other. Counting is wonderful, but subitizing comes first as a quantitatively meaningful process in kids' mind. So subitizing comes first, counting starts to grow, first verbal counting, then you learn correspondence, and then these 2 kind of meld together and keep going. So this important thing of 9, 10, 11, like I said before, and like one of you agreed with, the East Asian languages make it easier, but it does not mean we actually will do East Asian counting. We'll count with kids 9, 10, 10, 1, 10, 2, 10, 3. Oh, let's do it in English now. 9, 10, 11, 12, 13. Let's do it in Spanish now. And you relate these. You can easily do that with counting, but you can also do it with subitizing. That's going to come a little later than the counting actually for those high numbers, because conceptual subitizing is very demanding. To know all the combinations of 7. You can see 3 and 4 and just say 7. You can see 5 and 2 and just say 7. That takes a long time to develop. So, they might develop the ability to see 10 and 1, 5 and 10s frame. And 11 is at 5 and 10s frame and 1, but they're not going to immediately, of course, learn all the combinations of 11, which is what we mean by conceptual subitizing to that level. Anyway, back to here. Whoop, I forgot to say, in this, when we give you all these activities to choose from, we also give you this, this is the key, that when you're trying to help your students be a small collection namer, this is just 1, 2, and 3, very, very early, toddlers and the like. That's the key that you have to do. And then we talk to you about other activities. Here's tricky 2, okay? All it is it's a kind of like shell game without cheating. You hide 1, 2, and 3, and you move them around, and kids have to find the tricky 2 that's hiding from them. And the cool thing about that is there's nothing wrong. There's no mistake with picking the one with 3, and the teacher can do examples and non-examples. Is that 2? No. What's that? That's a 3. That's not 2. We don't do enough in mathematics with non-examples of a concept. It's very powerful to do that as well as examples. So we play snapshots, where kids indeed just see a quantity for a short time and point to a numeral. She's teaching them numerals. She has them pick up a numeral in that per thing. And then perceptual subitizing to 4, and we even have free. Kids can do these. Kids sign on in a different way, but they can do these too. This is just an online subitizing practice. So
You
click
are
on
getting
one,
closer to the planet.
and notice we do dots. We also do fingers. Oh, and listen, we don't start where you have to know your numerals. At first, you just match dots to dots, and a little easier. But here we do finger
You are-
brackets and everything else. So all that's free. And here's an example of a higher level. I tried to say, unless I'm rushing too much, that subitizing starts with the approximate number system when kids are a month old or less, some research says. And then it goes up to 2nd grade for sure, because this one only shows a little bit of place value. This shows what you were talking about with your cross the decibel kind of thing. If you
You
can
are making
see
good
that,
progress.
if you can see these as, what they are, oh, I got that one right. I wanted to get one wrong. We'll see if I did. These are videos that I don't have control over.
Watch your
This are just
dashboard
videos.
carefully and try again.
There's an error. So you see it again. Okay.
You are really close to the
Now I
planet
got
now.
it. You can
Just
also
ignore
press the
card.
peak button, but just one time. This is place value only, but we also have higher levels for 2nd grade where you'll see 2 10s and 4 and 3 10s and 5s. And you have to be able to say, whoa, 59. That's really a good antidote to any kids carrying the 1 without meaning. When they can kind of see these quantities and put them together, and there's nothing wrong with doing the algorithm too, but you want the understanding there too. And I'm going to have to skip. These are just a few more. This is what I was saying before. This isn't what we show kids. This is a representation of what we'd like them to do mentally, be able to say, okay, I can see the 8 in my head. I can see 5 in my head. I can think of moving these 2 over here, and I can see in my head what that is. I'm not going to show you this.
About this one.
Yeah.
Might be just too hard. to
Let's
do.
see. There we go. Whoop. Could you see it at all? No, not really. Doug, not a very convincing video. See that down there? So we're doing that with 2nd graders. So to see if they know can do the place value like that. I'm going to have to move on. I wanted to. What not to do? Okay, real quick, Doug. Kathy Richardson said, oh my God, when sometimes my kids, I only taught them dice patterns. And then when they made it, they would make an X or 4. So don't keep doing the same patterns. Use different arrangements. Very important for this process. And then let me just say a few words about formative assessment. Your essentials, your essential instructional practice 4 is formative assessment, intentionally and continuously embedded throughout learning. I love it. So much of what the research says is right there for you in those essentials. Let me extend those essentials to say, why do learning trajectories help with that? Because if you're going to do good formative assessment, you basically got to answer 3 questions. Where are you trying to go? Where are you now? And how are you going to get there? Right? Where are you trying to go is the learning trajectory's goal. Where are you now is the developmental progression. Everybody talks about start where the child is, but if you don't know the developmental progression for a topic, how do you interpret the kids' behaviors? Where are they? And most important, what is the next step for them, right? So that's what the developmental progression provides. And how do you get there? That's the teaching practices. How do you set up the environment? How do you interact with kids? And essentially, what are the instructional activities? For subitizing, we're going to move to higher numbers. We're going to move from perceptual to conceptual, that kind of thing. A lethal mutation that we have to watch out for is teachers without good professional development can confuse subitizing with counting. And I'll tell you, it ain't their fault, because if you do a search for subitizing activities that Julie did and put this together, 90% of the subitizing activities are counting activities. So they don't even elucidate for teachers, how is this different? How do the two interact with each other, you know? And so what I wanted to do now is introduce a little of the counting learning trajectory. I'm worried I don't have time, so I'm going to go pretty darn fast because I want to show you, several of you asked, right, questions related to subitizing and counting. How do they work together? So the goal for counting isn't, and we've been through this before, it's not rote counting. It's even for preschool, 3s and 4s, much less primary school. It's accurate, fluent counting, verbal counting, object counting, and counting strategies to solve problems, to compare numbers, to do arithmetic kind of problems and the like. The developmental progression moves from verbal counting and, oh my God, Doug, I can't skip slides because I love these videos. So real quickly, if you don't believe that verbal counting alone is really mathematical because you call it rote counting and you tend to think of things as rote as meaningless, right? Watch this girl when she gets to, I think it's 39. Take a look.
Please, count as high as you can.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. What comes after 3? I know 4. 41, 42, 43, 44, 45, 46.
That is mathematical thinking. She's not doing rote counting. She didn't even say what comes after 39. I know 40. She said what comes after 3. I know 4, 40, 41, 42. Whoa. Okay. The girl is 5. People, research a while ago, I hope it's getting better, showed that it's not till 4th grade that the majority of US students understood that 50 had something to do with 5. Because our language doesn't always help. It's not like the languages that say 510, 510-1. Kids don't relate it, but it's easy to do if teachers are aware that rote counting is not a good name for it. It's verbal counting, because if you know the structure, if I asked you what number, when you count, what number comes after 3,452, you would say 3,453. You didn't memorize that. That's not rote for you. You understand the system, and the system is mathematical. So object counting itself. And then what comes after you do know the verbal number words?
5, 6, 7, 8, 9, 3, 4, 5, 6.
All right.
All right.
Probably you know.
Thank you
The
very
next step after verbal counting is to learn one-to-one correspondence. And this girl knows she's supposed to point, but she doesn't keep one number word for each one. And in fact, if something's interesting over there, she starts looking in the distance and kind of just making pointing objects. Compared to this girl, who clearly is at the next level, what we call the correspondence.
Would you count these for me?
How many ships are there all together?
Thank you.
So I wish I could talk to you more about this, but I'm in a rush to not keep you extra. So I want you to compare that. Good. She went a whole level up. She keeps correspondence perfectly. But when asked how many, she recounted the set. Compare that to this little girl.
Yeah, I bought these bananas. I do too. I saw you eating them the other day when I was here. Could you count those bananas and tell me how many there are? How many? 5.
5. She knows the following level. Okay, so the developmental progression there is verbal counting, then correspondence, and then what we call counter small numbers. And all we mean by that is meaningful counting, where you know the last number word tells how many. It's often not emphasized because it's so obvious to adults that we don't think kids wouldn't know it. But that second girl, she never knows that the answer to how many is the last number word. We asked her a whole bunch of items. And if she counts 5 and you cover them or take them away like that assessor just did, she will just say 10, 100. So it's not a meaningful process for her yet. So this is where I was trying to get to link counting to subitizing. What I'm saying is, in this simple example, that if you develop the subitizing ability in conjunction with counting, so let's pretend you've developed subitizing to 5. Kids can subitize this, they can say 4. And then you're trying to teach them that the last counting word tells how many. How can subitizing help? Well, here, a typical way a teacher might teach is to set some blocks down and say, class, count with me. And the whole class would say 1, 2, 3, 4. And the teacher would say, fine, good. And maybe put a different number down. But there's nothing there that helps them, the kids who don't understand that the last number word tells how many, to do so. What did Julie and I do? We walk into the classroom with a hand behind our back, have the teacher do it, and say, you know those blocks we use? I was thinking, how many can I fit in one hand? Well, I put as many as I could hold in my hand. Count with me to find out. And then she would take one out, and the kids would say 1, take another one out, the kids would say 2, take another one out, 3, take the last one out, say 4, show her empty hands, and then point to gesture around all 4 and say 4. I could fit 4 in my hand. So later, I put these blocks out on the table. Your hands are smaller than mine. I don't know if you could hold 4 in one hand, but you can go see how many you could hold. So this is the point. I love to talk to people about what they think is different between the two lessons. And I have no time for that. So I will just say the first way you might have seen, when you said 1, what did you see? 4. When you said 2, you saw 4. When you said 3, you said 4. How is that connecting then what's going on with counting? In our way, when I pulled out 1, we said 1, you saw 1. Now, if you've developed your subitizing ability, you can easily say, oh, 2. Yeah, that's 2. I know 2. And then 3, I know 3. And even if you didn't subitize 4, you'd get the idea. And at this point, this and plus the gesture, plus the empty hands and that would really help. One lesson doesn't teach a kid a whole level, but this kind of activity uses subitizing to lend cardinality to the counting process in a way that's scientifically proven by Julie, Art Berudi, and some others to be very effective. When you're aware of what's happening, that's one way subitizing connects to counting. And before, do you remember the smartest girl in her class, at least according to her? That's a way the counting helped her say, okay, 15, that image, now I can file that away to conceptual subitizing to 15. So counting helped the subitizing. Here, subitizing is helping the counting. The two come together in a rich kind of way. Okay, so gotta start winding down here. I'm going to have to skip my geometry example, which I love, and maybe Trish will have Julie and I do that one in the future. So I want to show you some research. Here we are in 36 classrooms. Here is the learning trajectory kind of way we taught. Triad is just our scale up. It stands for Technology Enhanced Research-Based Instruction, Assessment, and Professional Development. The P didn't fit in the acronym, but otherwise it worked pretty well. This is business as usual. They had a curriculum, and listen, we did a powerful comparison by getting a non-learning trajectories-based curriculum, brand new curriculum for these 12 teachers. Exactly the same length of professional development here as in the learning trajectories. But here, all their professional development was designed and delivered by the authors of that curriculum. They just taught them to teach the lesson exactly like they wanted them to. We taught them about the lesson too, but we spent more than 50% of the time watching videos of kids thinking. This is where we developed the Learning and Teaching with Learning Trajectories website, actually, to teach teachers to think about kids thinking, know the levels, and adapt instruction like the Michigan Essential said about formative assessment to the kids' levels of thinking. The whole class might be at a kind of level, so you adjust to that, but you also have to adjust then for groups or individuals, right? And then this is teacher results. Teachers got much better. This is our big scale up study. 3 cities, three districts, Boston, Buffalo, and Nashville. The triad scale up kids did better than the control group with a strong, those of you that know effect sizes, standard deviations, about 3/4 of a standard deviation. And I'm going to have to skip some stuff here to get through it. Here's what I was saying way at the beginning. Language and literacy do not suffer. We gave the kids, the teachers were worried that they're spending more time on math. Would their literacy scores go down? Would their language scores go down? So we tested the kids. We didn't get this test together until they were in kindergarten. So they had the opportunity to forget this stuff all over the summer, but we went in there and we found no difference on letter naming. That was one of our tests, or 3 expressive language measures from the bus story test. It's you basically show these cartoons. There's many more of them, of a naughty bus that doesn't want to take the kids to school anymore, and then learns its lesson and comes back. And then you hand the pictures to the kids and said, you tell me the story now. So no difference on language except on 4 language measures. They used more key vocabulary words from the story. Most exciting, they used more grammatically complex sentences. This was not a math story, people. When you talk to kids about math, and I didn't mention this before, and I should have, we're always asking kids, how do you know? Can you show me? Can you explain your thinking? Kind of like the videos of that first girl, how did you get 9 take away 4? Well, I had new 4 and 4s, that kind of tell me how you got the answer. Raise the grammatical complexity of their story, their stories in a non-math area. They were more independent. They didn't need prompts to finish the story, and they did far better on inferential reasoning. So when I started this off and I said, math affects math, but it affects so much more, this is a dynamite example. We also raised executive function more. I'm going to skip the long-term impacts, but they were fun. So there is a science of professional development in early math too. I was I was on that NRC report on early mathematics. I was also on the early childhood care and workforce report. We know a lot about PD, and this kind of learning trajectory stuff just works. So I have to end. So early child curricula, often not scientifically valid. Choosing a book that you use in K-5 for continuity is equally effective. We really need to use the most important connecting tissue between early pre-K and into kindergarten and 1st grade is kids thinking and learning, is the use of formative assessment. To us, it's the use of learning trajectories that are shared. We also know professional development on these things is critical, and it really takes a lot of hours to do it well, and situating it in the school. The PD so-called training part has to be backed up by coaching in people's classroom, and the learning trajectory is really important. So I'm almost done. 50 seconds. I'll give the Michigan Essentials yet another kind of thing. Ensure equitable participation of children. We have incorporated, and I didn't talk about this before, inclusive teaching approaches and activities into learning teaching with learning trajectories that are based on our work with Frank Porter Graham people at the University of North Carolina for children with disabilities. So it's there. I will try to get you more information. But what we talked about today, early math has surprising predictive power. Young children have the potential to learn powerful math. Unfortunately, that's a surprise to too many educators. We know most children need better math, but we do know how to do it. Learning trajectories do the best to breaking down the false dichotomy of remediation, like we talked about, poor breaking down the math, and acceleration where learning trajectories builds up kids' understanding meaningfully. And math remains the queen of the sciences. It might be integrated into STEM, but it should also be taught separately. I was on this report too, the National Academies of Sciences report on STEM and science. So that's the end. Sorry, I went 30 seconds over. I'm watching the clock and sweating here, like, got to get through this. I didn't leave very much for time for questions at the end, but would be happy to state if people have time, or you can just contact me. The materials that you can download all have my email, which is douglas.clements@du.edu. And I promise you, you'll meet Julie and you'll like her a lot better than me because she's funnier. And usually I'm the butt of the joke. So this allows me to get some credence before Julie comes on and decimates your opinion of me. But we look forward to doing more with you in the future. Thanks, Trish. Thanks, Rusty. And I'm done.
Thank you so much, Doug. We really appreciate you making connections to so many of our essentials and a lot of the work that's already being done in Michigan. We really appreciate all that you did to prepare and for sharing your research with all of us today. In the chat, you'll see a link to a evaluation, and inside that evaluation, there's also a link for a form for credits. Once you click on that link, please make sure you go back and hit submit on the form so that we have some evaluation feedback. For those of you that don't know, Rusty just posted, there will be some future face-to-face sessions with Doug that he mentioned. He will be in Michigan for 2 days in October with some follow-up virtual sessions. So if you're interested, you can find information on our website that's linked in the chat. And we hope to see you there. We'll also follow up with an email that will contain a link to this recording, as well as a link for any registration. And the PowerPoint will not be shared, as we are instead sharing those 3 documents that were shared in chat today, and then also in the email for this registration.
There's one comment about the registration key. We'll get those out in the email, and maybe just highlighting again, the evaluation form at the end of that has the links for sketches or my registry credits, depending on which you prefer, or feel free to do both. So make sure you click on the evaluation form, complete that, and you'll also have access to sketches or my registry credit.
Finally, we appreciate you all signing on today. Have a great school year. I know this is the first day for many of you, or the first day is coming up, or maybe the first Monday. So thanks for choosing to be with us today, and consider ways that we can improve math education for our earliest learners.